In this lesson, we're going to look at moving objects in Rhino. To perform a move, you simply select the object and just drag it to the location you'd like it to end up in. If I click off of that, you can see the object is now moved. When you're working in the perspective viewport, the object will stay on the ground plane as you drag it. So as you can see, as I move the camera angle, it is still on the same ground plane as the rest of the objects. I'll just go ahead and click Undo or Control Z to get the object back to where it was. If I'm working in the perspective window and I'd like to move the object off of the ground plane, I can select the object and hold down the Control key and then drag the object up or down to move it above or below the ground plane. As you can see, as I move the camera, the object is now below the ground plane. Again, I'll hit Control Z to return that to normal. We can also go to our 4 views, select the same object, and then just drag it around in whatever viewport I'd like to move it visually. Whenever I'm moving an object in one of the orthographic viewports, it's only moving in 2 dimensions, so the object never moves towards or away from the camera when I'm in orthographic viewport. Let me go ahead and hit Control Z a couple of times to get that object back to where it originally started. And then enlarge the perspective viewport. And there we go, back to where we were. If I'd like to move an object with a little bit more control, Rhino has what is called O-snaps. And this is simply the button down here at the bottom of your screen. If you click on that, these option boxes appear, and you can check those to enable object snaps for whatever box you're checking. In this particular case, I'm just checking N snaps. So now if I select this object, I can't just drag the object and have it use the O snaps. I actually have to tell it to move. So the move commands can be found under Transform, Move, or this icon right here on the toolbar. If I click on that, the command line is asking me for a point to move from. So now using my object snap, I'm going to move the cursor to this corner of this box. And you can see as soon as I do that, it says End. I go ahead and click, and now I have mathematically grabbed the exact corner of that box. Since I have End checked in my O-snap control bar here, I can snap on anything that has an endpoint to move the object to. So as I move to the end of lines, you'll see that it says End. I can move to the corner of boxes. I can move to the starting point of the cylinder. I can move up. Now the object will snap above the ground plane, since the snaps overrule the ground plane constraint. And I can snap it to the top edges of the box as well. And now you can see if I move the view around, we are truly snapped right to the corner of that box. I'll go ahead and undo that. Now by switching on more of the O-snap constraints, you can have a little more control over your movement. If I select the box, this time I'll click on the midpoint snap, and I'll click my Move command here in the toolbar. This time I'm going to move from the midpoint of the object. I can move to an endpoint of a line, or I can move to the midpoint of another object, or I can move to the midpoint of a line. And let me undo that. If you'd like to have a little bit more control over your movements, you can switch on Smart Track. What Smart Track does is allows the object snaps you have selected to project themselves. And that sounds a little complicated, but it's really quite easy. So let me demonstrate what I mean by that. Let's say I want to move this box onto the top of that purple box. I'll go ahead and select Move. Let me change my view to Ghosted. It will make it a little easier to see what we're about to do. So I'll go ahead and float the cursor over the middle of the box until that midpoint snap turns light gray. Now that tells me I've got a midpoint snap. As you can see by this line, this light white line following the cursor, I have a smart track based off of that midpoint. And I can do the same thing over here on this side, and now that's changed white. If I move this cursor, you can see another smart track line coming off of this midpoint. If I move the cursor to the inside of the box, you can see the smart tracks still project, but now they overlap, and they show me where the intersection of that box is. I can click there, and I now know I've selected the center of that plane on the box. So I can go ahead and move that. I can move that up to the midpoint of this box, or here. I can move it to an endpoint, but I want to locate that right in the middle of the box. So since I've held the cursor here and I have the white points highlighted showing that my smart track is on this purple box as well. So now as I move the green box across the top of the purple box, my two snaps will align and I can just click release. So now the green box is aligned perfectly on the purple box. You undo. I can do the same thing with the cylinder. I'll just turn on my center snap and I'll turn off my end snap. Select the cylinder, select move. Now if I put the cursor near the edge of the cylinder, you'll see it says center. And now it's going to move the cylinder by its center, so I can align to the midpoints on the purple box. And that cylinder is now placed directly on top of that purple box. I can move a line in the same manner as you would a solid object. I'll click move, and I can move from a midpoint to another midpoint, or if I switch on my end snap, I can switch to ends, any of those. Or I can move a line to a solid or a surface using end snaps as well. And that's how we go about moving objects in Rhino. In this lesson, we'll look at rotating objects within Rhino. So we're going to go ahead and create a box for us to rotate. There are two ways to create the box. We can go up to the solid menu and come down here and select box and corner to corner height. Or we can come down here and simply click on this icon to start the box command. If we look at our command line now, it's asking us to place our first corner of base. And we can go ahead and click anywhere on the screen, but I want a little more precision, so I'm actually just going to type 0 and then hit enter. And that will place the first corner at the 0, 0 coordinates of our construction world. Now you can see the command line is asking for the other corner of base or length. I don't want this to be too large, so I'll just go ahead and type 15 for millimeters. And you can see immediately it's added that 15 millimeter length. For the width, I'm going to enter 25, click enter. And then for the height, I'll type 30 and also hit enter. So now you can see we have a box built. The whole thing isn't visible in all four windows. So I'll just come up here and right click on this icon, which will zoom extents for all viewports. And now you can see we can helicopter around. And we have a nice box just built right off of the 0, 0 coordinates. So let's go ahead and look at applying a couple of simple revolves to this box. First thing I do is select the box, and I can go to transform, and I can select rotate, or I can come down here to this icon on the toolbar and click that. Now you can see immediately the command line is asking for center of rotation. And I can come down here, and I do have my snaps on at the moment. I have end and mid snap, so I can snap either here for the end or here for the midpoint of the box. I'll just go ahead and click here for the midpoint, and now it's asking for the angle or first reference point. So I'm just going to drag my cursor up, so I'll just hold down my shift key and that'll constrain me to a straight line. And then I click again, and now I can just drag the cursor around, and you can see that's rotating the box for me. Keep in mind it is rotating around this midpoint, as that was where I selected for my origin. I'll just go ahead and press Ctrl Z to undo that. Let's look at that again. This time I'll use a different place for the center of rotation. So I'll click again on my rotate, and this time I'll just click off the rectangle somewhere. Hold down the shift key to constrain myself to a straight line. And now you can see it's doing something very different as I rotate. It's moving away from that line because it's revolving around this point over here, which is no longer on the line. Ctrl Z to undo that. Now the command we're using at the moment is just a two-dimensional rotate. So since we're in the top viewport, it's rotating along our main construction plane. This would be the same as if I apply the rotate command within the perspective window. You can see it's moving around the same way. I'll just undo that. If I come down here to the front viewport and apply the same command, you can see it's moving very differently. Now it's moving at an angle to the construction plane. I'll just undo that again. And if I come over here to the right viewport, apply the same command, now you can see it's moving differently through that construction plane. Now you don't have to just drag to rotate. You can type an angle if you want something a little bit more precise. So I'll hit my space bar to reapply the command. I'll use my snap to snap to the midpoint. And let's say I want an angle of 35 degrees. You can see in the command line it's asking for an angle or first reference point. When we were dragging up before, that was giving a first reference point. If we don't click anywhere and we just type a number, say 35, that's going to rotate the object 35 degrees from that center point that we give it. And I can go ahead and apply that command again in this viewport. This time I'll try a -45. And if we come up here to the perspective viewport, you can see the object has really moved around. Let me go ahead and right-click on Zoom Extents. And now the box is visible in all viewports. Now the box is on an angle. Let's look at what happens when I apply that Rotate 2D command again. I'll click one time to apply the command, once for the center of rotation, and I'll move around in the perspective viewport window. So you can see it's just rotating around this construction plane, much the same as if I just rotated it in 2 dimensions around the top viewport. Let me go ahead and Control-Z that to get that back to where it was. There is an option to rotate this piece of data in 3 dimensions. If I go up to Transform, I can select Rotate 3D, or if I come down to the same Rotate command, but this time right-click on it. Now I'm in Rotate 3D, as you can see up here in the command line. It's asking me for the start of the rotation axis. There's a couple more things you have to pick to constrain the move with Rotate 3D, but it's not too bad. Let's walk through it. So the first click is going to be on this corner, and now it's asking for an end of rotation axis. This is different in the 3D rotate than it is in 2D rotate. And basically what it's asking me is to create another line, sort of like an axle for this part to rotate around. So for this, we'll keep it simple, and I'll just click right here on this end piece. So now if I move around in the perspective viewport, you can see this white circle that's being drawn, and you can see it's on an angle, and that's showing you the path this will rotate around. So we're no longer rotating right around the construction plane anymore. Let me apply that command again. We'll do a little bit different. This time I'll use a midpoint to confine my rotation axes. So now it's as if there's an axle across this point. Let me go ahead and apply a 2-dimensional rotate, just so you can see the difference again. So now I'll click here, constrain, and as you can see, the part will always move in relationship to the construction plane you're working from, be it the front right viewports or the top and perspective viewport. And that ends the lesson for rotating objects in Rhino. In this lesson, we'll look at copying an object in Rhino 5. As with many things in Rhino 5, there are multiple ways to achieve a task, and whichever method you choose will depend on your particular modeling situation. The first method is the traditional copy and paste. We'll just go ahead and select this box, and we can either go up to Edit and select Copy, or you can see the keyboard shortcut Control-C, which is the one I'll choose. I'll choose Control-C, and you can see in the command line it says Copy to Clipboard. I can go ahead and do a Control-V to paste, or select Paste from the Edit menu. And now if I deselect the box and reselect it, you'll see Rhino is asking me which one of the 2 objects I'd like to choose. And that's because there's 2 objects that are mathematically overlapping right where I've clicked, and Rhino doesn't know which one I want to select. I'll just pick one of those, and I'll hit delete. Now if I click again, you'll see it just selects the box, because that is the only piece of geometry in that particular location. I'll just go ahead and move this box out of the way, deselect it, And then I'll do another Control V to paste the instance that we copied earlier. And you can see it paste that box directly where we had previously copied the part from. Let me just do a couple of undos. Now the second way to copy has changed a little bit in Rhino 5. In Rhino 4, if I wanted to drag and copy a part, I would drag it and hold down the Alt key and then let go of the mouse when I had the piece move to where I would like it go. This no longer works. Let me undo that. In Rhino 5, I drag the part, and as I'm dragging it, I just tap the Alt key, and you'll see the little plus sign appear. And then I can let go of the part when it reaches where I want it to move to. And you can see it's left a copy behind. I can do the same with this part. I'll just drag it over here and tap Alt. And I can drag this part here and tap Alt again. This time if I helicopter around, you see we have 4 instances of the same object. I'll just undo those to get back to one part. Now there are 2 versions of copying in the menu, and I'll show you the difference. I'll go ahead and select the part. And if you remember, we selected Edit, Copy before to actually make a copy of the part. If you go over to the Transform menu, however, you'll see another copy. If we select this one, you can see the command line is asking us for a point to copy from. So I'll go ahead and click End, and that becomes my reference point for any other copies I make. Now if I click, you can see I've made a copy there, and I can just kind of continue clicking and adding objects wherever I want them to go. I can use my object snap and snap to the middle of a part or to the end of a part. And I can also go back to my 4 views and use one of my other viewports to place parts while I'm working. And remember, when I'm finished with the command, I can either hit Enter, Spacebar, or right mouse click to apply the command. If I go back to the perspective window and zoom out just a little bit, you can see we've made a lot of copies now, placed all around, and they all use the endpoint for their locations. Let me go ahead and just drag some boxes and delete the excess parts we have here. And we're left back with the single part that we originally started with. Now there are several other copy commands you use quite frequently in Rhino. The next of these is called the mirror command. You just go ahead and select this model. And for this, I'll go out to my top viewport. I'll go to Transform, and I'll select Mirror. I have my end snap on, so I can just snap to the endpoint, and I'll just drag a bar up. And essentially this line I'm dragging is if I were drawing a mirror right here, and anything on the right side is going to be mirrored over to the left side. So now you can see I have 2 boxes. I can select both of those, apply the mirror command again. This time I'll select this endpoint, and I'll drag this way. And now you can see I have 4 boxes selected. So it's going to mirror everything I've selected across the mirror line or across the line of symmetry that I input. Let me just undo that. Now you don't have to snap to a part on the object to apply the mirror command. Let me select the object. I'll hit spacebar to apply the mirror command again. And you can see my command line is asking for the start of the mirror plane. This time I'll click out here in space, and I'll drag. Now you can see I've created 2 parts, a little further apart this time. I'll undo that. You can also use a line as your reference for your mirror and snap to that. So if I select this part and go to the mirror icon, and this time snap to the endpoint of this line, my parts now have symmetry across this line. This can be very useful for a lot of your designs. A lot of times you'll find you're building things that are symmetrical, and this allows you to just build either the right, left, or top or bottom side of a part, and then simply mirror it over when all the details have been added, saving you a lot of time. Let me go ahead and delete these parts. Now the next type of copying we'll look at is called a polar array. And this is when you array your parts in a circle around a particular center point. So I'll go ahead and select this part, and the array command can be found under the Transform menu, and it's this icon right here. So now it's asking for the center of polar array, and I can use my Smart Track here to find a part that's in the center of this box. I'll go ahead and switch Smart Track on. So I get a line coming from the midpoint of that box and just click. You can see instantly on the command line It's asking me for a number of items, and this will be the number of items that it rotates around the center point. In this case, I'll just go ahead and type 6 and hit enter. It's also asking for the angle to fill or the first reference point. I want this to fill just a simple 360-degree angle, and you can see that's already within these brackets. So I can just go ahead and hit enter. If I zoom out a little, you can see all 6 parts, and the command line is asking me enter to accept, or I can go ahead and click on items equals 6 and change that number, let's say to an 8. Now I've added 8 items to the scene, and again, you can see the command line is asking me to press enter to accept, or I can go ahead and click items or fill angle to change either of those. I'll just go ahead and hit enter. Now it's applied the command, and you can see if I enlarge the perspective viewport and zoom around, there are in fact 8 copies of this box rotated around a center point. Let me go ahead and undo that, and now we're left back with the original box again. The final kind of copy that we're going to look at is called a rectangular array. You can find that on the transform toolbar next to polar array, and this is called rectangular array. Or you can go to the transform menu and select array rectangular. And you can see my command line is asking me to select an object to array. I'll press enter to apply the command, and it's asking me for the number in the X direction. I'll type a 4 in this case. Number in the Y direction, I'll leave that as a 3, and the number in the Z direction, I'll just leave that as a 1 for now. And you can see it's now asking for unit or X spacing. And in this particular case, I'll just click down in this corner to give it an origin point. As soon as I've done that, I can start dragging my cursor. And when I find something I like, I can just click, and you can see it's added 4 boxes in the X direction, 3 in the Y direction, and we have 1 set of boxes in the Z direction or the vertical direction. Let me just undo that, select and apply the command again. So I'll go ahead and apply 4 in the X direction, 3 in the Y direction, and we'll enter 2 for the Z direction. I will click to give the boxes an origin point, and then I can drag out just as I did before for the X and Y direction, and then click. And now I can drag to apply a Z direction. So there you go. Now we have 4 in the X direction, 3 in the Y direction, and 2 as we entered in the Z direction. Go ahead and undo that. Let's go ahead and apply that command again. This time we'll type in numbers instead of just dragging. So let me select the part, select rectangular array, number in the X direction, I'll change that to 5, number in the Y direction, let me change that to 6, and Z direction will leave that at 1. So for unit, cell, or X spacing, this time I'll type a 30 for the X spacing. For the Y spacing, I'll type a 60, and you can see the result. We now have 5 of the boxes in the X direction, and we have 6 of the boxes in the Y direction. And that concludes our look at copying in Rhino 5. In this lesson, we're going to look at scaling objects in Rhino 5. Before we can scale anything, we need to build an object that we can scale. So in this instance, we'll just go ahead and build a box. So I click on my box icon here, and we'll go ahead and place that at the 0 world coordinates. And you can see it's now at the intersection of the red and green lines in all 4 windows. And you can see in the command line it's asking for the other corner of the base or length. To keep this easy, we're just going to make these all 10. So we'll enter 10. For width, we'll enter 10. And for height, we'll enter 10. As you can see, that gives us a nice even 10mm cube. I'm going to dimension this just so we can see what the scaling changes do. So I'll go up here to the standard toolbar, click on linear dimension, and using my snaps, I'll put 1 dimension there, 1 dimension here, and 1 dimension here. And I'll drag that out in the front viewport. Go ahead and make the perspective window larger. So you can see we have a cube that measures 10 by 10 by 10. To access the scale menu, you can go up to transform, and then select scale, and then choose any of the options: scale 3D, 2D, 1D, and non-uniform scale. or the same options are available under the Scale menu down here on the toolbar. Since we're going to spend a little bit of time in this, I'm actually going to tear off this toolbar and just put it up here so we have access to it the whole time we're working. So when we look at the toolbar, you can see there are 4 icons here, and we have 3D scale, 2D scale, 1D scale, and non-uniform scale. And we'll look at all 4 of these in a moment. The first one we'll look at is 3D scale. If I click on this, you can see the command line is asking me to select objects to scale. I'm going to pick the dimensions as well so you can see the effects of what we're scaling. I'll just go ahead and hit enter. Now I have everything selected. And it's asking me for an origin point. Rhino needs to know an origin point or a point to scale from in order for it to work. So I'll just click there, and you can see the command line has changed, and now it's asking us for a scale factor or a first reference point. We'll do this a couple of ways. The first way is by using a scale factor. So essentially what we're looking at doing is entering a percentage we want to scale the model. If I entered a 1, that would be considered 100%, so the dimensions would all stay as they are. If I enter 1.5 and hit enter, it's going to consider that to be 150%. And you can see, sure enough, it does scale up. Now all the dimensions are 15 millimeters because a 3D scale is going to scale it uniformly in the X, Y, and Z directions. Let me go ahead and hit undo just to get that back to where we were. Alright, I'm going to apply the same command, so I'll just hit the space bar. You can see it's asking again for the origin point. I'll click. This time in the command line where it's asking for scale factor or first reference point, I'm actually going to click right here. Now by doing that, Rhino knows the distance between those 2 points is exactly 10 millimeters. So now any number I enter isn't going to be a percentage I want to scale, it's going to be an actual dimension I want to scale to. So I can be a lot more precise. Let's say I want to go to 12.25. So I'll type 12.25 and then I'll just press the enter key. And you can see instantly the cube's updated and it scaled itself to 12.25 in all directions. Now so far I've been using an endpoint as the origin, but I don't have to do that. Let me go ahead and hit the space bar to apply the command again, and I'll switch on my midpoint snaps, and let me turn on Smart Track. So by using Smart Track, remember I hover over the middle till that turns white, and on this side I'll do the same thing, and then I'll move the cursor to the center and I get an intersection snap. So I'll click there, and now we're going to scale from the dead center of this cube. So let me go ahead and enter a scale factor of 1.5. And now we've scaled up 1.5 from the center of that cube. And I'll go ahead and undo that and deselect. So let's go ahead and look at the 2-dimensional scaling. Again, I'll select everything in the scene so that we can understand how this is scaling. I'll click on the Scale 2D icon. Again, it's asking me for an origin point. I'll just give it the end point. And for a scale factor, we'll enter the 1.5 again. Now you can see that it looks a little different. We have a dimension of 15, a dimension of 15, and this time the Z direction didn't change. It's just a dimension of 10. Remember, we learned previously, Rhino considers working in the perspective window similar to working in the top window and refers everything back to this construction plane. Let me go ahead and Control Z. And this time we'll move out to the top viewport and we'll do the same thing again. I'll hit 2D scale, click once for the endpoint. This time I'll give it an end snap. So now it knows that distance is 10 millimeters. This time I'll type 21.5 and hit enter. Let's enlarge the perspective viewport. And you can see, sure enough, we have 21.5, 21.5. And because we are only scaling in 2 dimensions, the Z direction has not changed. Undo that. And remember, 2D and 1D scaling rely on the viewport that you're working on for their reference. So we'll go ahead and hit 2-dimensional scale. It's asking for an origin point. I'll just click there. Scale factor, we'll type 1.5. And you can see if I expand the perspective viewport, we're looking at this cube from this direction. And sure enough, it scaled it to a 15 and to a 15, but it hasn't changed the Y direction at all, since the view we were looking at was a ZX view. Let me undo that. And this time we'll go to the right viewport, which you can see is a ZY viewport. I'll go ahead and click on 2-dimensional scale, come back down to the right viewport and click the end snap. and I'll type 1.5 again. Increase the perspective viewport. And sure enough, you can see now we've scaled the box along the Z and the Y direction. So we have 15, 15, and the X direction didn't scale. Let me undo that. So that's the two-dimensional scale. One-dimensional scale is very similar. I'll press one-dimensional scale, select my objects to scale and press enter. And now I'll click here and then click here. It knows that distance is 10, so I can type 12. Press enter, and sure enough, this is still 10, this is still 10, and this is now changed to 12 because we're scaling in one dimension. Go ahead and undo that. Press this again. This time I'll click on the endpoint here, and I'll give it a scale factor of 1.5. Now, because I haven't assigned a second point, you can see it's moving around and skewing because it doesn't know what direction I want to work from. So I can hold down Shift and go in either X or Y direction here. And as soon as I do, it changes that to 15. One thing you need to be careful with working with 1D scale is you can actually skew an object. So let me go ahead and undo that. I'll press one-dimensional scale. This time I'll click here for a midpoint. But instead of clicking here, I'm actually going to click on the top. So now we've drawn a diagonal. So that will be the reference for my one-dimensional scale. And as soon as I start to move, you can see the cube starts to get skewed. And if I go down into my orthographic viewport, you can see sure enough the cube is now more of a diamond shape. Let's go ahead and look at the last scale option. What the non-uniform scale does is allow me to scale in the X, Y, and Z independently, all based off of the same origin point. So I'll click on non-uniform scale. It's going to ask me for objects to scale. I'll hit enter. It's asking me for an origin point, and I'll give this origin point here. That's going to be the same origin point for all three of the scales I'm about to do. Now it's asking me for a scale or first reference point. I'll click here and then type a 12. And click again to apply it. Now you can see the command line is asking for a Y-axis scale. So I'll click back here in the Y direction. And I'll type 13.5, enter, and now it wants to move in the Z direction. So I'll click here for a reference point, now I'll give it a dimension of 15 millimeters. Enter that and then click to apply it. As you can see, our cube has an X dimension of 12, a Y dimension of 13.5, and a Z dimension of 15. So it's scaled independently, all based off of this origin point. And I'll just undo that. So there you have all four scaling options within Rhino 5. So we're going to look at locking and unlocking objects in Rhino. The reason you want to lock your objects while you're working is it still allows you to reference the part visually while you're working without accidentally selecting it, and your object snaps will still work. The two places to access the lock commands are up here under the Edit, Visibility, and you can see the lock commands right here. Or right on the main toolbar, you see this padlock icon here. If I hold down and expand this toolbar, you can see there are 5 options here. I'll just go ahead and pull this toolbar off so we have access to it while we're looking at this. The first option is Lock. The second is Unlock. Then we have Unlock Selected Objects. We have Invert Selection and Lock Objects. And we have Swap Locked and Unlocked Objects. You'll find you probably don't use this Unlocked Objects icon too much, since if you look at the Locked Objects icon, you can left mouse click to lock or right mouse click to unlock the objects. So let's go ahead and do that. We'll just left click on Lock Objects, and the command line is asking us to select objects to lock. I'll just go ahead and select a few items here. Now anytime Rhino is asking you to select objects, and you're going to select multiple objects, you don't need to hold down the Shift key like you typically do to select multiple objects. You can just go ahead and click on the items and it will add them. If you've added too many items or you've added a wrong item, if you hold down the Control key and then click on that object, it will be removed. As soon as I have the object selected I'd like to lock, I'll just go ahead and hit the space key to apply the command. And remember again, you can hit space, enter, or right mouse. All three of those will do the same thing. And you can see instantly I now have 3 dark grayed objects. And dark gray is the default lock color. You can see I can no longer click on those items to select them. But as I mentioned, if I try to draw a line, I have my object snaps on. You can still snap to the locked items. The way we go about unlocking these is we can click on Unlock Objects, or just right-click on this icon. And as you see, they change from the dark gray to show that they are no longer locked. Unlock Selected is a very handy feature, and the way we go about using this is let's select 3 objects we'd like to lock. So I have the object selected, and then I can click Lock. So those are locked. If we click on this, everything that is currently unlocked disappears, and the only thing on the screen is the locked objects. So now I can go ahead and select whatever I would like to unlock. Let's say in this case, it's going to be this cube, and then just hit Enter. As soon as I hit Enter, the screen returns to normal. Everything that is unlocked currently shows up, and the locked items are still there in dark gray. If I apply the command again, there you can see the items that are currently locked. I'll click on this one to select it, hit Enter, and now you can see that item is unlocked, and this curve is currently the only item that is locked. This icon, the Invert Selection and Lock Objects, can be quite handy if you have very complex scenes or you have data that is very close together. Sometimes it's very difficult to select all the parts that you might want to lock. So what this allows you to do is to select a couple of objects that are perhaps a little easier to grab in your scene, and then press this button. It will actually invert the selection and lock the newly selected objects. So let me just go ahead and click on this and you can see what I mean. So you saw a brief flash as these became selected and then those became locked. Let me undo that and redo that again. This time I'll select these. So now when I press this button, these 3 parts will become selected and then lock. This icon allows you to swap your locked and unlocked objects. And it can be quite handy if you have a lot of things you need to lock and unlock at one time. Let me just go ahead and click this. And you can see immediately everything that was locked became unlocked and everything that wasn't locked became locked. Let me just click that again. So you can see that works quite nicely. As I mentioned when we first started looking at this, the default locked color is this dark gray. I personally don't like to work with it this way. And if you'd like to customize how your locked items appear, it's really quite simple. We simply click on this Rhino Options icon, and we go to Appearance, Colors, and you can see locked objects are set to a dark gray. I can just click on this and change it to any color I'd like. I'm just going to make it kind of a warmish blue. Click OK. And as you see behind the window, the locked items have updated themselves to sort of a monochromatic blue color. We can go one step further, which I usually do. Under Advanced Settings, if I open up this menu, select Objects, you can see it says Locked Objects. Locked Object Use is by default set to Use Application Settings, and that's just telling it to use the same color I just changed to up in the Color menu. What I always change is the Locked Object Appearance. By default, locked objects appear solid. I like them to appear transparent, so I can click on that, and I might make that transparency say a 50%. Go ahead and hit OK. So now my locked object is transparent, and I like this because when I'm working, as I said, a lot of times your scenes can get complex, and if you have a lot of locked items, it allows you to see through those parts while you're working. You can see if I'm drawing and snapping to a part over here. If I didn't have this set to transparent, I wouldn't be able to see through the object to be able to draw a line coming off of that part. And as I said, it can just be quite helpful as your scenes become more and more complex. And that concludes our look at Rhino's locked objects. lesson, we'll be looking at how to hide objects in Rhino. Hiding objects in Rhino is fairly handy. It allows you to take a scene with a lot of parts in it, and by hiding certain parts on a layer, it cleans up the scene without actually having to move those parts to a different layer. It also allows you to hide construction lines or any parts that you want to save for later and bring them back when you need them to work in your model. The hide and unhide menu is very similar to the lock menu, and we access it in two ways. We can go to Edit, Visibility, and you can see the different visibility options here. Or we can come over here to this light bulb, and this top row is all our visibility options. Let me just drag this toolbar off so we can work with it. So the first option is hide objects with a left mouse click or show objects with a right mouse click. The second is show objects. The third is show selected objects. The fourth, invert selection and hide objects. And the fifth is swap hidden and visible objects. So the way we go about this is select the objects you'd like to hide and simply click the Hide Objects button. These objects have now disappeared. They're still on the same layer, they're just no longer visible and no longer selectable, and because they're not selectable, your snaps will no longer work on them either. To bring an object back, we can either click on the Show Objects button, let me go ahead and hide those again, or we can right-click on the Hide Objects button to bring them back. If we want to hide multiple objects, we can click Hide, select the objects that we'd like to hide, and hide them. We also have the ability to bring back selected objects, and that's this icon called Show Selected Objects. So I'll click on that, and immediately anything that is visible goes away, and the only things showing on our screens are items that are currently hidden. So we can go ahead and just select whatever objects we want to bring back, and then press Enter. And you can see we brought back the 3 objects and left the 1 curved line hidden. I'll go ahead and right-click on this to bring everything back. We also have the ability with the Hide command to invert selection and hide. So I can select a couple of objects that are much easier to select than others, let's say. Click on this button. It'll invert the selection and hide the new selection. Just bring those back. I also have the option of hiding objects and then swapping out everything that is hidden for everything that is hidden, and that's clicking this icon here. As you can see, the hidden objects and the visible objects have swapped places. I'll click that again, and now everything that was hidden is now visible. Go ahead and right-click on that to unhide everything. And that concludes our look at the hide objects in Rhino.